Welcome. In this video, we will show you how to generate and analyze a secant pile wall excavation with internal bracing with DeepEX. We will create the 2D excavation model with the DeepEX model wizard. We open the wizard and we define the desired analysis method and settings. Next, we select the option to create a model with struts and we define the project geometry. We can define the excavation depth, the wall position, the water table, the strut section properties and spacing, and more. In the Soil Types dialog, we can create a database of soils and define the soil properties for each soil. In the Borings dialog, we can create the model stratigraphy by defining the top elevation and soil type for each soil layer. In this example, we will use a top fill soil followed by a sand, a glacial till, and a rock. In the next tab, we can edit the wall section properties. In this example, we will use a secant pile wall with reinforced concrete piles. We can adjust the pile diameter and spacings and see the edited section. In the Reinforcement tab, we can adjust the reinforced concrete section longitudinal and shear reinforcement. In the Stages tab, we can define the depth for each bracing level. In this model, we will use two levels of struts at 2.5 meters and 5.5 meters from the surface. In the Surcharges tab, we select to apply a 15 kPa load for 8 meters behind the wall. The wizard will produce the model with all stages. We can access and edit each item on the model area. Here we access each wall and edit the wall depth. In the Analysis tab, we can adjust the analysis method and the methods for water pressures, soil pressures, and more. We select to run the analysis. In the Analysis and Checking Summary table, we can see critical results for each structural element. In the Model area, we can see several stress graphs for each stage. We can also see support results and structural checks. In the Optimize tab, we can select to optimize the support structural section and click on a support. The program offers a list of sections and the structural checks they would give is applied, and we can select any of the available sections. We can run the analysis again and see the new results, result graphs, and check ratios in seconds. In the 3D World tab, we load the 3D Model Wizard and we select to create a 60 meters by 16 meters rectangular excavation model. On the generated model area, we can access and edit the positions of the generated struts and corner nodes. We can analyze the 3D model and we can see the critical results and structural check ratios for each generated strut and waler. We can also see steel connection checks and a cost estimation for our project. In the 3D model area, we can see result graphs and check ratios. In the 3D FEM tab, we can create the 3D FEM model for all construction stages with the click of a button. We will access the FEM settings and change the FEM mesh to medium. In the same dialog, we can adjust the 3D FEM model limits by editing the X and Y axis coordinates. We can generate the 3D FEM mesh with the click of a button, and we can see the generated mesh on all elements in the 3D FEM model area. We select to perform 3D FEM analysis. The duration of the analysis depends on parameters such as the model dimensions, the number of construction stages, the mesh density, and more. When the analysis is completed, we can see the critical results and structural check ratios for each support and waler in the results table. On the 3D FEM model, we can display FEM shadings results for the soil mass, the walls, and the supports. Here we show the horizontal displacements and the soil settlements for different construction stages. We can select to hide several elements such as the soil and the water surfaces. We can display various result shadings for the supports and the walls. Here we illustrate the support axial reactions and the wall moments on the strong axis for different stages. Thank you for watching this video. Visit our websites and find out how to overcome your geostructural challenges with our programs.